Hey everybody, my name is Alex Merced, part of the Subsurface team, the tech advocacy team here at Dremio. Welcome to another one of our Subsurface meetup events. Always a good time, this one being themed around the basically amazing hot topic of data mesh. But before we get started, I'd like to just call attention to a few things. One, very soon, March 1st and 2nd of 2023 will be our next Subsurface live conference. So on top of doing these regular meetups, we also do an annual conference. So keep an eye out for that. Sign up for the thing so that we can get updates on as we get closer to the event. But also, if you'd like to speak at the event, we do have a call for speakers going on where you can submit your talk to speak at the Subsurface conference event. Just a little anecdote, one of our previous meetup speakers and conference speakers, Matt Topo, from talking about Apache Arrow at different Subsurface events, he ended up getting a book deal and a job offer. So, it's always good to put yourself out there, and definitely go submit a proposal for a talk on the Data Lakehouse space over there at dremio.com/subsurface/live. Again, that'll be March 1st and 2nd, 2023. But with that, let's get on with today's meetup event, where we're going to be having two great talks on data mesh. Okay, again, during the talk, you can ask questions. Just ask the questions in the chat, and then I'll curate them so that way at the end of the talk, we can then relay them to the speaker. And again, the recording of this will be posted within about 24 to 48 hours after this is over. So you will be able to watch this again afterwards. Okay, but our first talk is going to be with Sven Balnojan who's data ops at Meltano. Also, he's a co-author of Data Mesh in Action. Okay, and I will introduce him for his talk, the Pragmatic Data Mesh Crash Course. Sven, the stage is yours.
Thank you. So let me quickly share my screen. There we go. You should now see my screen. And yes. Okay, thanks. So let's get started. Welcome everyone to a Pragmatic Data Mesh introduction. We are here today to, I'm trying to help you figure out if the data mesh is something for you, okay? So you already heard something about me. My name is Sven. I'm a data ops evangelist at Meltano, and I write a lot. For instance, the book Data Mesh in Action and a newsletter. I also have this Python project, which is called Build a Small Dockerized Data Mesh, where you can, in Python play through some things you could do inside a data mesh. And, I've been writing about the data mesh for a couple of years now, actually. So what will you get out of this talk? My goal is to basically spike your interest, to give you some guidance on whether this data mesh thing is something for you, whether you want to implement a data mesh, right? And my method is going to be, I'm going to show you a real-world example taking from a medium-sized company, because this is kind of my minimum viable example, because most examples of a data mesh out there are usually at large companies, and I'm going to show you that it works in like small and medium-sized companies just as well. Just, it's just going to be smaller. The prerequisites, you should have heard the word data mesh before, but that's about it. I'm not going to go into technical details, not into many details at all, and I'm not going to aim for completeness, okay? I'm really here to spike your interest into the topic and help you see whether you want to implement a data mesh, right? Notice I said implement, not build, because let's start with important things first. You cannot build a data mesh. The data mesh is first and foremost something about organizational, people, and cultural changes, and then the technology kind of follows that change, okay, in a way. And I'm going to explain it in one way, in what kind of way, right? So let's get started with the definition of the data mesh. So if you Google data mesh, you will end up with something like this. Data mesh is a socio-technical paradigm shift. And then there are lots of fancy words following that definition. So my co-authors and I came up with something that we consider a little bit more pragmatic, because we find these definitions really hard, and definitions matter. So what we came up with is what we call the what, why, and how definition. So for us, the data mesh is about decentralization at its core, and decentralization in terms of culture, like in terms of who does what, and in terms of technology. Why do we want to decentralized, well, we're aiming to increase the value we get out of our data. Okay, that's the whole idea. More value from our data. And how are we going to do that? Well, in the data mesh world, we are going to do it guided by 4 so-called principles, which are implemented inside the data mesh, but these vary a lot in different implementations of the data mesh. Okay, so you'll have lots of freedom here. So, but of course, like decentralization is not the only way to extract more value from your data, right? You can also scale up your analytics department. You could implement some fancy technology, right? To figure out when you want to use the specific solution, to get more value out of data, I'm going to tell you the story of a company called Unite, which is a large European B2B procurement platform where I helped to implement a data mesh. Okay, so this is the data world at this company in 2017. There's a large central data lakehouse in the middle, maintained by a central data team. On the left-hand side, you see lots of tables from a production database, a few REST APIs, CSV tables that all get ingested into the central piece. And then a few things go out of the central piece, like reportings and dashboards and machine learning models. So this company was already implementing machine learning in one of their most important use cases. So in this picture, this stuff works, right? Data flows from the left-hand side to the right-hand side. If something breaks on the right-hand side, the central team, they've become experts in various domains, and they're able to fix things very quickly. They're also able to deliver on new use cases because they know all the domains, they know the use cases, so that works. But research from a German called Jan Nitschke shows that at companies that implement the data mesh model, this doesn't work anymore for a very simple reason. You see on the left-hand side, there are data producers. There's something in the middle. And on the right-hand side, there's the data consumer. And so there is a gap between producer and consumer. And what Jan Nitschke has shown is sometimes this gap actually is overloaded. Okay, so this is overloaded. There's a bottleneck in between, and suddenly stuff doesn't work anymore. So at the company Unite, around about the time when I joined the company, it looked like this. Boom. So things changed, right? So this company made a few big changes. One, on the left-hand side, in the data producer domain, they introduced a microservices architecture. So that meant they didn't just have like a bunch of REST APIs. They suddenly had like dozens and dozens of APIs of different kinds and different nature that all needed to be ingested into the central data lakehouse. And on the other side, they also made a business change, like a large business change, suddenly becoming much more data-driven and much more focused on actually combining different sources of data. So what happened here is like this explosion on both sides suddenly overloaded the central bottleneck. So then, we sat together and we thought, okay, so what are we going to do? We could scale up the analytics department to meet this demand, but we realized there's like an additional problem. It's not just that both sides grew in size, but that they were also changing rather quickly. Because on the left-hand side, with microservices and domain-driven architectures, the teams were actually, the software teams were iterating quite quickly. And on the use case side, the business landscape changed quickly. So both sides were changing quickly. And that's where we realized, the old model just doesn't work anymore. So, and the problem took on a very pragmatic form. Like before these major shifts, the lead time for like implementing new use cases, new dashboard, machine learning model with new data sources meant, sourcing new tables, maybe 1, 2 APIs. It took a couple of weeks. Okay, so like writing it down, understanding the use case, prioritizing it, implementing it. That's like a couple of weeks lead time. After these major shifts, the lead time jumped to 3 to 6 months, which in our eyes were like unacceptable lead times. So we started to look into the problem. We realized this data mesh idea is pretty interesting. So we started to tackle these new use cases. So we realized there were 2 major ones. One was of operational nature, I would say. We were talking about like automating, sending emails, for instance, when like certain events that are a combination of different data sources, happen. And then there was analytical, which was mainly product-related reporting. I'm also sourcing many different sources into like one kind of report and dashboard. And we also identified the decentralized actors. So there were the data producers, a bunch of software engineering teams, which were now pushing new microservices. And there were, on the data consumer side, one decentralized business analysts, which were taking data from these sources and turning it into reports and dashboards, and some operational engineering teams, which are actually building marketing automation solutions, things like that. So what did we do? We decided we are going to take the data mesh ideas and decentralize these new important workflows out of the old picture. So in the data flow, this looks like this. Now at the bottom, we still have the old working system, because now it's not overloaded anymore by these important use cases. And the important use cases are on the top, and they don't go through the central data lakehouse anymore, and they also don't go through the central data team anymore. So it means we're now decentralizing these two use cases in a way that connect producers of data on the one hand side and consumers on the other side directly without interference. So the technical way we did that was to build a custom tracking solution where there is lots of freedom in the data that can be put into that, but not total freedom. So enough freedom that puts the responsibility on the data producing teams. So basically, the development teams, like inside their new components, when they publish a new component, they also include this tracking and the specific tracking codes that send data to the data consuming teams. And this turned out quite nicely, for the company. Before the data mesh, we had 3 to 6 months of lead times, and with the data mesh, suddenly we went in use cases where we needed like new data sources. We suddenly went from to lead times of a day, because it simply meant add this tracking snippet and publish the component again. Sometimes there also is the need to add new platform functionality, new tracking solution functionality, and that means we actually need like 2 to 3 weeks, because the central data team that maintains this tracking solution has to change something. But that's about it. Okay, so we were like really, really quickly suddenly. Now, I hope you're going to say, wait a minute. You said something about cultural, right? That's a technical solution, right? And a pretty easy one, right? It's like a tracking solution. Yes, that's why I said in the beginning, the technical part is not as important as the cultural part. Let's take a look at what the people now do, right? Let's compare that. And I like well, my test basically is the Ghostbusters test, right? Like, who you're gonna call, right? So what does now happen when something breaks, or when something goes wrong, or when someone wants something new? When an analyst in this new world, now once it realizes things like there's a data point missing, he builds a report and he's like, but I'm pretty sure, the revenue from last year shouldn't be this low. Then in the old world, you would then go to the central data team, and then the central data team would investigate and figure out the problem. But now he goes to the data producing team, to the development team, and asks them, hey, this data should be there. I know this solution works quite fine. Where is the data? You're the domain experts. You should be the ones telling me where it is. And the software engineering teams usually are able to do that, because they're the experts in the domain. If a development team wants to consume a new data, for instance, for like sending out a new email or triggering something else, then they actually now go to the product manager for the data producing unit, which is the development team. So suddenly product management is involved in the data work, right? If a development team wants new platform functionality, so like a new feature added to the tracking solution. An example would be like in the first iteration, we did not build out the operational use cases. That was like a second iteration. Then they go to the central data team. So you see there's a shift of responsibilities inside the company, like inside the software engineering teams and the data teams and the product management. So quite a large shift. And that did not emerge out of nothing. It took some serious work to get there, and it took a good foundation. So these shifts of responsibilities are built upon 4 principles in the data mesh world, and that's where we also build it on. So I'm going to explain these 4 principles and illustrate them in an example. So the very first principle you should know about and the one you should start with is distributed domain ownership. And the idea is that in the software engineering world, you have this idea of cutting down your software into domains and then having like one owner per domain. And you have the you transfer that idea to the data world, where you say, now, for each of my data pieces, I should actually have it owned by one domain, which is allowed, like by one team, which is allowed to become a domain expert in this data. Okay, so it should be able to become an expert. And how exactly this plays out is actually not that important. So at Unite, we made the software engineering teams that produce the data also the owner of the data, that were already like experts in the data. But you could also have like sister team, like Spotify has like this idea of sister teams, I think, having like an analytics team next to like each feature team. And you can also embed like data engineers inside teams. So there's a variety of ways. What's important is you should have the ability to become an expert in the data, right? That's distributed domain ownership. The next principle is called data as a product. And the idea here is that data shouldn't, in the old world, the central data team sources data from a production database. But the production database usually is like the data store of applications. It is not really meant to be read from external sources. So that's kind of like it's a byproduct. And the idea is that this should now be wrapped into a data service, which provides, for instance, like SLAs and be subject to usual product management. There should be the ability to add like data points to a data service, right? So how this played out at Unite, first of all, of course, this tracking solution wrapped these data services almost automatically. But even further, the product management now has to weigh off actually feature development and data development, which is an important point because they actually need, the data to develop the features, and they suddenly are in line and can make these decisions and weigh them off properly. The third principle we implemented at Unite is called platform thinking, and there's a very simple idea. Building data services is hard. You might need things like dbt, Airflow. You might need to know about Parquet, Iceberg, things that are very special knowledge. And on top of that, you're duplicating them across like different teams, like these mesh nodes, for instance, that unite the software engineering teams. And if you do that, like having duplicated effort and specialized people inside each of these teams, it's not going to work out. So you want to try to abstract that away, make this work easier, and enable everyone to use it. So you abstract it away and put it into a platform. So at Unite, the central data team that built the tracking solution, built a platform, the tracking solution, and this became a partial platform team. The last principle of the four is called federated computational governance, and the slide is mostly empty because we did not implement it at Unite. Simply because we didn't need it so far. But I'm going to tell you what it is. So it's called federated computational governance because in the world before the data mesh, data governance is a very centralized topic. If you move to a decentralized world, centralized governance doesn't work anymore. So you need some kind of, but just decentralized governance also usually doesn't work. You need to kind of like unite things to ensure company alliance, to ensure that everyone's working towards one goal. So that's where the word federation comes from, where you have like central body and the decentralized bodies and put them together into a federation and let them make decisions in terms of governance. Computational enters the picture because if you decentralize things, you cannot block them by manual processes. So you do need to automate that. So hence the word federated computational governance, which can take many different forms. You will need some kind of federation and some kind of automation, but you don't need to start with it off the bat. So as I just said, you should start with one principle, the distributed domain ownership. And the reason I'm saying that is because in part, the research by Janicke showed, so Janicke is a German who wrote his master's thesis actually on the topic. But for that, he surveyed lots and lots of companies that actually implemented a data mesh. And what you ask them is like actually dug into their setup of the data mesh and surveyed their usage of the different principles. And what he found out was that they're very, very different across the board. Some very few actually implement all 4 principles, and they, in terms of which principles they choose very differently, but they have one thing in common: they all start with distributed domain ownership. And the reason is that, for me, it's this is the decentralization aspect, the organizational decentralization aspect. So if you want to start a data mesh, keep in mind it's an iterative process, and you want to start with distributed domain ownership, with trying to get the company and the culture to change, right? And that's a hard thing. Whenever I talk to developers about that, I always get this response. I explain to them the data mesh, and they say, yes, we get it, totally, we agree. You shouldn't have to deal with like breaking schema changes inside databases. We're on your side, but could you please talk to our product manager to prioritize this kind of work? And that's, for me, the sign that, yes, the cultural shift involving product management has to come first. So if you want to have this is my kind of checklist. If you know this consumer producer gap is your problem, then I would say go ahead, identify 1 or 2 use cases where there's money at stake, not just toy use cases, because decentralization is always more costly than centralization. So you need something that's actually worth the effort. For these use cases, you go out, you brainstorm and discuss with product management, tech leads about the responsibility shift. Not about the technology, it's about the responsibility shift. And if they agree, you start to work on the kernel, the technical implementation. And by the way, a technical implementation of a data mesh could just be a README file. This is how we do it. This is how you should structure your data in Databricks, or in our open lakehouse. My hint: if you don't get a data producer to test this with, you probably do not have buy-in. Okay, so you do need to have data producer to test this with. In our book, Data Mesh in Action, we also have a whole chapter walking you through workshop techniques and stuff. But the Data Mesh learning community also has some of that stuff, because one of our authors also published stuff there. So you can just check that out if you're looking for workshop material, or these kinds of brainstorming sessions for this cultural shift, right? So we're already at the end. So what I want you to take away are basically 2 things. 1, you do not need all principles. That's, I think, a common misconception. You start with distributed domain ownership. That's the point. And the second thing, it's a little bit more subtle, but if the consumer-producer gap is not overloaded, if that's not your problem, then there actually is likely a better solution than the data mesh. Okay, that's what research has shown. Data mesh is a costly thing. It's a hard thing because of this cultural shift, and there might actually be a better solution to your problem if this is not your problem, right? All right, so thank you for listening.